This video will demonstrate how to use the QCT Pro 3D Spine Analysis module. First, we will open the file by clicking the 3D Spine icon, selecting the file 3D Spine Analysis Basics from the training folder, and opening it. The study opens to the patient information screen. The purpose of the patient information screen is creation of a database record for the patient. The fields will already be populated with information entered during the scan setup. Patient name, patient ID, date of birth, and sex are mandatory. All other fields are optional. Notice the blinking Add New Record button. Throughout the analysis, your next required action will be prompted by blinking labels. Verify the information is appropriate, modify it accordingly, and then click Add New Record. Your indication that the record has been successfully created is the match changes from None Found to Confirmed. Click the Extraction tab to go to the next step. Three functions occur in the extraction screen. 1. The spine is located for analysis. 2. Calibration information is obtained from the phantom. And 3. The vertebrae for analysis are defined. The spine isolation and phantom ROIs are automatic. Evaluate the image for a successful extraction. The spine crosshairs should be in the center of the vertebral body. The phantom should be enclosed in the phantom box and ROIs visible in the phantom. It is not necessary or recommended to adjust the spine center crosshairs if auto extraction is successful. Occasionally these functions will fail and require that you intervene. If the spine crosshairs are mispositioned, drag the crosshairs to the center of the vertebral body. If the phantom box fails, move the box to surround the phantom by dragging it. You may also change the size of the phantom box by right-clicking the mouse button and pulling it. This may be necessary, for example, if the failure is being caused by a high-density object such as a zipper in the phantom box, and you need to exclude this object. In the Tools area at the bottom of the screen are found image navigation buttons, window width and level presets. The Localizer button toggles between display of the axial and any localizer images. Axial magnification button for the rotation images and scan information. These buttons jump to the last and first images in the study, respectively. These buttons display the next or previous image. These buttons display the next or previous images in increments of 5. Window width and level can also be adjusted with the mouse by putting your pointer over the image and with the right mouse button down, scrolling on the image. The Axial Localizer button toggles between display of the axial and any localizer images. Clicking the back button when the first image is displayed will also display the first localizer image. The Auto Magnification button enlarges the image displayed on the subsequent rotation screen. Larger images are easier to work with, but in some circumstances, it may be necessary to defeat this function by unchecking the box. The Print Image button prints the image currently being displayed and allows you to add a notation. Click the check boxes corresponding to the vertebrae you intend to analyze, L1 and L2 in this case, then click the Rotation tab to go to the next step. Rotation is the process of repositioning the spine in software to facilitate the placement of a standard ROI for QCT spine measurements. This is the software equivalent of tilting the gantry with two-dimensional single-slice QCT. 3D volumetric QCT adds tilt in the sagittal and coronal planes for full orthogonal control, which is not possible with CT gantry angulation. This is particularly advantageous when the patient has scoliosis. The goal of rotation is simple. Rotate the spine until it resembles a vertical box. Rotation is simple. Put your pointer on the image and drag it around the axis of the image plane in the direction you want to rotate. Two tools are provided to assist you with rotation. Intersection crosshairs are yellow crosshairs shown in the axial, sagittal, and coronal image planes that provide a quick means for navigating through the extracted 3D image volume. The crosshairs mark the location of the intersection of the three orthogonal displayed image planes. The crosshairs are repositioned by dragging them. The displayed image planes will be updated to reflect the location of the new intersection point after repositioning. For example, moving the intersection crosshair on the axial image will define new sagittal and coronal image planes. The blue dashed lines are for visual reference only and are moved by dragging them. They do not directly impact the data analysis, but they may be helpful in judging the orientation of the vertebrae, as will be demonstrated later. The ROIs are automatic, but failures occasionally occur and adjustments are necessary. Always inspect the images and ROIs. If the auto ROI appears successful, it is recommended that you do not adjust it. You can rarely improve a successful auto ROI. The ROI should be in the anterior 1/3 to 3/4 of the vertebral body. Cortical bone should be excluded. The basivertebral plexus should be excluded. And exclude any abnormalities you might see in the images. If an ROI needs to be adjusted, you can change the location, size and shape, and the height. To change the axial location, drag the ROI. To change the size and/or shape, push-pull the ROI with the right mouse button down. To change the vertical location, move your pointer to the yellow ROI boundary box seen on the sagittal image and drag the ROI up or down. To change the height of the ROI, select the corresponding vertebra from the Height menu and select an appropriate size. To view the images in the coronal view, select Coronal for the reference image. The automatic ROIs were initially correct, so no actual adjustments are necessary on this example. Click on the Results tab to go to the Results screen. The Results screen is a view-only screen showing the outcome of your analysis. The Results screen shows the patient compared to norms, absolute BMD values, Z and T scores, and fracture prevalence. Click the Report tab to go to the last step. This is the last step of the analysis, where the analysis results are saved and reports may be printed. The results must be saved before reports can be printed. Click on Save Exam Record. Exam report saved will appear below the button and the Print Report button will activate. Reports may now be printed. Information such as a doctor's name and an interpretation can be added to the report. In this example, we will add a doctor's name and interpretation using templates previously defined with the list editor. This concludes the analysis of this 3D spine examination.